All right. Greetings, YouTube. Beautiful mind here. Oh, actually, let's do it like this. All right. So, beautiful mind here. This is going to be our live full lecture for calculus. If you are in my support for college algebra course, you that lecture is actually pre-recorded, so I loaded it, so it's there. It's just you have to search in my videos and you can find it, but it's there. So for calculus, let me see. So this will be our last lecture before spring break. So this is the lecture for week 3 Friday, for spring of 2020. A few announcements. Let me turn this down just a little bit. A few announcements. Hello. Sorry, I was just trying to check my audio levels. Let's see. So key points that we need to make sure that we're doing. One, let's make sure that we're forwarding our GMC email to an email that we check regularly. Let me turn it down just a little bit more. Okay. So one, we want to make sure that we're forwarding our GMC email to an email that we check regularly. Two, all students should have full access to Pearson. So we were given complimentary access code. So if you do not have full access, there's an access code in the announcement section of Moodle. Okay, so we should all have full access to Pearson. I went on and loaded the quiz for this week. So I loaded it yesterday. It's been up since yesterday. It is due this Saturday at 11:59. So just go ahead and check it out. It should take you no more than like 20 minutes. You get unlimited attempt. So that means you can get whatever score you want up until this Saturday. After this Saturday, the highest you can get, I think, should be like 20% off, which is like a 80. The third thing is that, oh yeah, be sure to be subscribed to my YouTube channel with your notifications turned on, so that when I go live or I post video responses and things of that nature, you'll get a notification, just so that you can be aware. You can decide if you want to tune in live or whatever. There also is a participation in honesty quiz in Moodle, so we want to definitely make sure to get that submitted as soon as possible. Check the deadline for that. If it's not today, it's more than likely going to be by this Saturday by 11:59. Okay, so to recap, one, be sure that we're forwarding our GMC emails to an email that we check regularly. Two, we should all have full access to Pearson. That's how I'm going to be monitoring homework, quizzes, and exams. Three, be sure to be subscribed to my YouTube channel with your notifications turned on. And four, there's a participation in honesty quiz in Moodle that we need to go ahead and take and submit. Okay. All right, so I can't think of anything else. So without further ado, we're going to go ahead and move into the material for today. So there are two sections that I'd like to do today. And I'd like to start with section 3.3, Rules of Differentiation. So to me, these are fun. So where in the past where we introduced a derivative, again, for our context, the derivative at a point is going to be the slope of the tangent line at that point. And the derivative function basically tells us the slope of the tangent line for any given value of x, right? So we extended the notion of the slope of the tangent line at a point to the slope of the tangent line across the entire domain. Okay, so then that's what we mean by the derivative function. So in the past, we were using a quotient definition. We were using a couple of different definitions to talk about derivative. So we actually have some shortcuts here. These are my favorites. Like I don't know what it was, but I got it when I was a student. Like actually, this is my last topic that I did in high school. First topic I did in college. I enjoyed it. I did well. I loved it, and I hadn't looked back. I've been paid to have fun ever since then. So I don't know, but this topic was what, I don't know what it was, but it just made sense to me, and it was more or less easy. And so yeah, once you get past those definitions that we did last class, to me this is like the easiest part, and it's like the meat and potatoes, and like this is what most of calculus is about. This next topic. So let's start with we have the constant rule. So C is a real number. The derivative of a constant is going to be function. So if you think about it, a constant function, the graph of a constant is just going to be a flat horizontal line. If derivative is the slope of the tangent line, if you pick a point on the flat horizontal line and you draw a tangent line as best you can, what kind of slope would that tangent line have? It should be a flat horizontal line as well, and that slope should be 0. So this makes sense. So the derivative of a constant is going to be 0. Okay, I think that logic is fine. So next we want to look at the power rule at the bottom of the screen. If n is a non-negative integer, then the derivative of a power function x to some non-negative integer. So the shortcut is basically the exponent comes down and we subtract 1 from the exponent. Okay, so derivative of a constant is 0. Derivative of a power function is the power times x to the power of n minus 1, right? Okay, let's keep it moving. It looks like a lot, but it goes very quickly once you do it. So here's a proof. I kind of want to do this proof, but I'm going to just kind of read along, right? So, for instance, if we consider the power function and we use the definition of the derivative in this form, f prime is going to be the limit as x approaches a of y2 minus y1 over x2 minus x1, where n is 1 and f of x, with n being 1 and f of x being x, we'll get something like this. We get 1. With n is greater than or equal to 2 and f of x being x to the power of n, let me see. So f of x minus f of a is x to the n minus a to the n. A factoring formula gives, let me see. Oh, power rule, right? So you can say x minus a times x to the n minus 1. So this can factor into all of this. So then f prime of a is going to be the limit as x approaches a of basically this guy. These cancel. We're left with this. And then this is kind of showing this is the same as, and they're going to be n terms here, which is going to be n times a to the n minus 1. That's a proof. It's a little bit, it's kind of like this. Don't worry about that. That was just me kind of playing around. But the main thing here is just basically the derivative of a constant is 0, and the derivative of a power function is going to be n times x to the power of n minus 1. That's the main thing. And once you see the shortcut in action, you'll like it too. All right, so let's give this example a go. All right, so we're asked to evaluate the following derivative. So we're just going to use the rules that we just introduced. So let me go like this. This is awesome. You can't see the side stuff anymore. This is fantastic. Okay, so let's give this a go. I'm just going to do, actually I like my dark blue. So we're going to go example 1a. Let's see, evaluate the following. So we have d by dx of x to the power of 9, right? So the power rule that we just introduced, this is going to be d by dx of this is going to be 9 times x to the power of 9 minus 1. So this is going to be 9 times x to the power of 8. That's it, right? So what this is, given any x, this will produce the slope of the tangent line for any given x for the original function, okay? Let's do part B, example 1b. We want to do d by dx of x period, right? If we apply the rule, the same rule, this is going to be, so the exponent comes down. We're going to have 1 times x to the power of 1 minus 1, which is going to be 1 times x to the power of 0. Any non-zero to the power of 0 is going to be 1. So this should just be 1 there, okay? And then let's do C, example, I just want to make sure, example 1c. We want to do d by dx of 2 to the power of 8. Notice that this is just a constant, right? There's no x here. So 2 to the 8, let me see. So this should just be 2 to the 8, right? There's no x. Let me see, 2 times 2 is 4. Let me see, I know 2 to the 5 is 32, 64, so this should be 128. Okay, let's see, how do we do? Let's see, how do we do? So 9x to the 8, 1. Oh, it's a constant. Duh, I totally just got that wrong. Being a little bit airy. Okay, that's okay. So yeah, derivative of a constant is just 0. I totally just blanked out. I got that wrong. That was my fault. Yeah, it's a constant, right? We just said that. The derivative of a constant is 0. Okay, that's okay. Let's see. Constant multiple. So now, I'm just going to use the theorem. So the constant multiple rule. If f is differentiable at x and c is a constant, then the derivative of a constant times a function is going to be the constant times a derivative. Okay. So the derivative of a constant times a function is going to be the constant times the derivative. Okay, let's see this in action. So this is going to be example 2a. We're asked to do d by dx, or find the derivative of, 7x to the 11 over 8, okay? So this should be the same as that constant, which is the negative 7 by 8 times d by dx, the derivative of x to the 11, right? That's going to be negative 7 by 8 times 11 x to the 10. Come on. It's not going to undo for me. Okay, it's not behaving properly. X to the 10, all right? Nothing cancels, so then ultimately that's going to be negative 77 over 8 x to the 10. This is what we got as a result. Let me do the following. This is fine. I'm just going to move all this to one line. Okay, so this is what I got for that one. And then let's go ahead and do example 2b, or not 2b, example 2b. We're asked to find d by dt of 3/8 times the square root of t, okay? So this is going to be the same as that constant times the derivative, 3/8 of d by dt of, and I'm going to rewrite this, instead of the square root of t, I'm going to say t to the power of a half. Okay, so then this is going to become 3/8 times a half times t to the minus 1/2. Ultimately, we're going to get 3 by 16 over the square root of t. Now again, I'm a fan of rationalizing. I noticed that like before the book didn't really rationalize. Let me see. So we can, so basically going to be 16 times the square root of t. I did 3 right there. I think this is it. I'm going to go with this. Let me see. I think this is okay. Let's shrink it down. I just want to shrink it down and get it onto one line. Oh no. Undo. Can we try that again? There we go. That's better. And then we want to take all of this right there. Boom. Okay, let's see how do we do. So for number 1, we're on example 2. We got negative 77 over 8. X to the 10 is good. And then we got 3 over 16 times the square root of t. 3 over 16. Yeah, I don't know why they're not rationalizing. Again, usually we don't leave it with a radical in the denominator, but for some reason this text has been doing that, so, you know. Scusi. We're going to go with it for right now. Okay? So if we were in each other's presence, this will be a moment where I will pause to see if there are any questions. Again, if you do have questions, write them down and reach out to me and we'll make sure to get them answered, okay? Next, we'd like to talk about this sum rule. So the derivative of the sum becomes the sum of the derivatives. So it's almost like you can pass the derivative function. It's almost like a distributive, but it's not really distribution. It's just a rule. There's a proof. I'm going to let this be for now just for the sake of simplicity, and I just kind of want to work an example or two. So we have this example. It says determine the derivative of this polynomial. So let me start by getting a copy of the original. So here's example 3. And we're asked to determine d by dw. So take the derivative with respect to w. We got 2w cubed plus 9w squared minus 6w plus 4, right? Okay. So if we take the derivative of this, we just said that the derivative of the sum becomes the sum of the derivative. So we can rewrite this as d by dw of 2w cubed plus d by dw of 9w squared plus d by dw of this plus d by dw of 4, okay? So then if we apply the rules that we literally just introduced a few minutes ago, I'm just going to just jump straight to it. I'm just going to apply the shortcut. So 3 times 2 becomes a 6. This becomes 6w squared plus 18w, let me see, minus 6. And the derivative of a constant goes to 0, okay? So then the derivative of the cubic function, we finish with this square root function, this squared function. Okay. Let me see, was that it? Okay, let's see how do we do. We got 6w squared plus 18w minus 16. 6w squared plus 18w. We got minus 16? Did I write the original wrong? Oh, minus 6. Okay, yeah, we're fine. I just read it wrong. Okay, so I think we got the same thing there. Okay, I'm just going to kind of let that be for right now. I just want to kind of jump here for simplicity's sake. So now we have this number e, right? So the number e is this decimal 2.718 blah, blah, blah. It satisfies that the limit as h tends to 0 of e to the power of h is going to be 1. This is the base of the natural exponent for e to the x, okay? So then with the preceding, we ultimately get something like this. So when f of x equals e to the x, d by dx, or the derivative of e to the x is e to the x, okay? So the derivative of e to the x is itself. So in this example 4, we're asked to find the equation of the tangent line to this graph at this point. So basically what I'm going to do, I'm going to find the derivative. So, okay, write the equation of the tangent line. So I'm going to find the derivative and then use this value of x to find the slope of the tangent line. And then we'll just, find the equation on the line. And then for part B, it says find the points on the graph for which the tangent line is horizontal. So basically that's saying take the derivative and set the derivative to 0, okay? So let's start by getting a copy of the original. So this is going to be example 4a. We have f of x equals 2x minus e to the x over 2. I'm going to say at the point 0, negative 1/2. Okay. So let's start by doing f prime of x of this. Let's see. Derivative of 2x is just going to be 2. This is going to be 1/2 times the derivative of e to the x, but the derivative of e to the x is itself. So it's going to be minus e to, e to the x over 2. So this is going to be the derivative. So then we're going to say the derivative when x is 0 is going to be 2 minus e to the power of 0 over 2. E to the 0 is 1, so that's going to be 2 minus 1/2, which is 3/2. Okay, so that's the slope of the tangent line when x is 0. So then the equation of a line, we're going to use y equals mx plus b. So our y is negative 1/2. Our slope, which is this guy here, this is our slope. Our slope is going to be 3 by 2. Our x is 0, and we don't know our y-intercept. So now we can see that our y-intercept is going to be a negative 1/2. So the equation of our line is going to be y equals 3 by 2x minus 1/2. So this should be the equation of the tangent line at that point. And then for B, find the points on the graph at which the tangent line is horizontal. So basically what they're asking us to do is take this f prime of x equal to 2 minus e to the x over 2. Again, this is example 4b. They're asking us to take this derivative and set it to 0 and solve, right? Let's see if we can do it. So let's see. If we do the inverse operation at the couple of steps, add and multiply, we're going to get, ultimately we'll get e to the x equals 4. Okay. And then to solve for x from college algebra, to cancel out the e, we would take the natural log of both sides. If we take the natural log of both sides, all right, this x can kind of come down. The natural log of e, they cancel, those are inverses of each other. So they're going to cancel each other out. On the left, we're going to get x. On the right, we're going to get the natural log of 4. So let's see. Find the point or points on the graph at which the tangent line is horizontal. So when x is equal to the natural log of 4, the slope of the tangent line should be 0. Okay, I think this is okay. Let's see, how do we do? So we got 3 over 2x minus a half for the first one. And you see it here. And then we got natural log of 4 for the second one. You see it here. Let's see. Yeah, natural log of 4. Okay, here. Okay, that's the gist of it. Let's look at this example. So for example 5, it says the slope of a tangent line, let this be our f of x. For what values of x does the line tangent to the graph have a slope of 6? So basically what this is saying is find the derivative, set it equal to 6, and solve. Okay? All right. So let me start by adding a page here. I feel like we might not need any more space. If I need more space, I'll add some. So here's our f of x. That's going to be equal to 2x cubed minus 15x squared plus 24x, right? If we go ahead and find the derivative, so f prime of x is going to be, let's see, 6x squared minus 30x plus 24, right? Then it said to set it equal to 6, so we're going to say 6x squared minus 30x plus 24. We're going to set that equal to 6. Now, if we go ahead and set it to 0, we're going to get, let me just go ahead and add a page. So if we subtract 6 from both sides, we'll get 6x squared minus 30x plus, what is that, 18 equals 0. Notice that we could factor out a 6 from everything. I'm going to divide all the terms by 6, so then this will give us x squared minus 5x plus 3 equals 0. We want to jump straight to something of this form. We got x and x. This plus tells us the signs are the same. This one tells us the larger one is negative, so that means they're both are negative. Two numbers, nope. We don't have two numbers that multiply to give us 3 and add to give us 5. So I'm going to use the quadratic formula. Or, yeah, let's use the quadratic formula. So quadratic formula goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Here we see that our a is 1, our b is negative 5, and our c is 3. Okay, if we keep going, we get that x equals 5 plus or minus the square root of 25 minus 4 times 1 times 3, square root of all of that, divided by 2. Okay, so then this gives us 5 plus or minus 4 times 3 is what, 12? So that's 8 and 5 is 13. That's going to be the square root of 13 over 2. So then we get these two irrational numbers. So what values of x? These two values of x are going to make the slope of the tangent line equal to 6. Okay, let's see, how do we do? We get 5 plus or minus the square root of 13 over 2. For part B, yeah, you see it right here. 5 plus or minus the square root of 13 over 2. Then you know how to find those decimals. The hardest part, we're past the hardest part. Ooh, good chucker. Okay, so again, as you kind of make your way through these, just, if you have a question, you have to write it down and you have to reach out to me. Give me just a moment. And we are back. All right. So yeah, I think we got those. So let's kind of keep moving forward. So let's look at this. We have this definition on higher order derivatives. Assuming y equals f of x can be differentiated as often as necessary, the second derivative of f is going to be, so f double prime of x is going to be d by dx, or the derivative with respect to x of f prime. Okay, so basically we take the derivative twice. For integers greater than or equal to 1, the nth derivative of f is going to be d by dx of f to the n minus first derivative of x, okay? So basically, we can just kind of keep taking the derivative on certain functions and see how they appear. Other common notations for the second derivative. The second derivative of y with respect to x, and then, or this, and these, okay. So find higher order derivatives, find the third derivative, or finding higher order derivatives, find the third derivative of the following functions. So we asked to find the third derivative. Okay. So let's give this a go. So this is going to be example 6a. The original, we have f of x equal to 3x cubed minus 5x plus 12, okay? So let's start by finding f prime of x. 3 times 3, that's going to be a 9x squared minus 5. Again, remember that the derivative of a constant is 0. Then let's just take the derivative of that again. So now f double prime of x, 9 times 2 is going to be 18x. Again, derivative of a constant is 0. So they want us to do it a third time. So then f triple prime of x is going to be basically just 18. Okay, that's for 6a. And then let's go ahead and do example 6b. If we have y equals 3t plus 2 e to the t, we're just going to do y prime. Y prime, or we could say dy by dx, I'm just going to do y prime, that's fine. It doesn't really matter. And that's easier for me to keep track of. 3 times t, that derivative is just going to be 3. Remember, the derivative of e to the t is just going to be itself. So we're going to have this 2 times e to the t, right? And then y double prime is going to be derivative of a constant is 0. Again, the 2e to the t is going to be the same thing. It's just going to be itself again. And then y triple prime is going to be, again, itself again. Okay? So we get this one for the second one. Okay. So we got 18 and 2e to the t. You see the 18 there, and you see the 2e to the t. All right. So that was an introduction to some of the rules of differentiation. Those are some of the shortcuts. So you see how, like, on the last few lectures on 3.1 and 3.2, you know, we had to go through these long, drawn out, you know, algebraic things. Well, mathematicians noticed that there were shortcuts. There were patterns to those. So they would, you know, long story short, these rules were the patterns that mathematicians in the past noticed, okay? So, so we can use them, and let's kind of keep going forward. Let's see. So we're going to move into section 3.4, product and quotient rules. So we've talked about a power rule and a constant rule. So we talked about a sum rule, right? So now we want to look at a product rule. I'm going to let that be. I'm going to just kind of jump into the rule. Okay. So if f and g are differentiable at x, then the derivative of the product, okay, so the way I remember the product rule is the first I usually do the first times the derivative of the second plus the second times the derivative of the first. That's how I do product rule. I think they did the derivative of the first times the second plus the second times the derivative of the first. Sorry. Derivative of the first times the second plus the first times the derivative of the second. And anyway, I usually do the first times the derivative of the second plus the second times the derivative of the first. That'll work. I'm going to let all this be and I want to just kind of work an example. So we have this example. We're asked to find d by dv of these examples. So let's give this a go. Let's give this a go. So we have example 1a. Let's see. So we're asked to find the derivative with respect to v of, we have v squared times 2 times the square root of v plus 1. Okay. So we have the product rule going on here. So we're going to say the first, which is just this, times the derivative of the second, so d by dv of the second thing, which is this. Then we're going to say plus, so the first times the derivative of the second plus the second, which is this, times the derivative of the first, d by dv of v squared. Okay. All right. So then let's find all of these parts. So then we have our v squared that just comes down. So then the square root of v, we can look at that as v to the 1/2. So then we're going to get 2 times 1/2 v to the negative 1/2, okay? And then the derivative of a constant is 0, so that 1 is gone. Okay, and then basically these two are going to go to 1. I'm going to let that be for just a moment. Let me see, am I doing this proper? I think I'm okay. And then this 2 times the square root of v plus 1 just remains. And the derivative of v squared is going to be 2v. Okay? So, let's see what else. So then we have v squared divided by v to the 1/2. We can make an adjustment there. Let me see. Let's see if that helps us. I don't know if that's going to help us to distribute or not. Let me just kind of glance to see how they wrote the answer. So they did write it that way. Okay. And that's not supposed to be equal. We're going to say plus. So now, if we distribute, this guy, we're going to get 2. So v to the 1/2 times v to the 1 becomes v to the 3/2 plus 2v, okay? V squared divided by v to the 1/2 becomes 1/2 again. So that looks like 1.5. So that looks like that's another v to the 3/2 plus 2v to the 3/2 plus 2v. Hopefully I'm doing this proper. Let me see. That went to 0. That persisted. That was 2v. We distribute it. Let's kind of take it all home. So 1 plus 2 becomes 3v to the 3/2 plus 2v. This is what I get. We're going to compare to what they have. Okay. Let's see, how do we do? 3v to the 3/2 plus 2v. Totally off. What did I miss? 2v. Oh, did I just stop writing that? No, it's there. Let me see. V to the 1/2. I'm gonna have to go back over this one again. Oh, 5. Okay, we just missed something. Okay, let's go back and be a little bit more meticulous. Okay, so here, let's go line by line. So now the original, we got this v squared, 2 times the square root of v plus 1. That's fine. So then the product rule is the first, which is here, times the derivative of the second, you see it here, plus the second times the derivative of the first. Okay, I feel like that line is fine. Let's go to the next line. So then when we take the derivative here, it's going to be 1/2. The 1/2 is going to come down. The 1/2 comes down, and we have v to the minus 1/2. Okay, 2 times a half is a 1. So that's just v to the minus 1/2. And the derivative of a constant is 0, so that 1 should be gone. Okay, so that should just be v to the minus 1/2. Okay, I'm going to let that be. V squared is going to be 2v if we distribute. Oh, I see where I made a mistake. So when we distribute that 2v, that's supposed to be a 4v to the 3/2 right here. This is supposed to be, and let me mark it in red, that's supposed to be a 4v to the 3/2 plus 2v. Yeah, that was it. Okay, so then this, oops, this was supposed to be a 4. And then 4 plus 1 gives us our 5. Cool, we weren't too far off, but that's how it goes. Let's see. I want to say, now I know some of the more advanced graphing calculators can actually tell you the derivative. I think I'll try an example or two to see if I can do it in a TI-83 plus. Let me try it in this one since we just did this one. I know the 89 can do derivatives. I'm not sure about the 83, 84 plus, but let's take a look at it and see if we can find anything. I just want to do a new one actually. Let's go here. So let's look. Let's refresh and reload, and let's see if we can find something that'll tell us the derivative. I know if I had an 89 plus, I know that one can do it. I'm gonna go over here to math. That might be it. In derivative, calculate. Let me see. Let me go. Can I go there? dy by dx, right? Let me see. Okay, let's try it. So I'm gonna go to y equals, and I'm gonna type in the original. So the original we have is x squared times 2 times the square root of x plus 1. Okay. Let me think about it. Let me try one place first. Let me go here to math. Absolute value. It's not those. Polar. Okay, let's try this. Let's try number 8 of that function. Let's see if what that does. Let's see with respect to x. I think that's how that goes. I got to think about how to do it. Let me get rid of this respect to x part. In derivative. Let's say, comma, first derivative with respect to x. Let's try that. Okay, I got to let me look up this syntax. In derivative. Oh, I didn't realize that was still out, but that's okay. I'm gonna do a quick search. Let me see. Find the derivative on TI-84 plus, right? How do you find the derivative on the graphing calculator? I just want to see some text. Press that. Yeah. In derivative, that's right. Oh, we have the graph. Trace zoom necessary and the lower. Okay. I don't know that it'll spit it out for us though. That's what I'm really trying to do. I know we can use the graph. I don't know what's there. Can we go back? Try this one. Okay. Method 1. Graphing. In derivative. Go to the home. In derivative. First argument. This. Second variable. Comma x. and x value where you want the derivative. The third argument, the x value where you want the derivative. Oh, the value of x. Okay. Okay. I know we can look at the graph. Let me try it one more time. So from here, what if I get rid of this and let x be 1? Go to. What if I get rid of this? Okay, let's go to y equals. Let me suppress this and just let it be x squared. And then let's go to variables. Let's do y2. And let's say with respect to x, when x is, let's do when x is 0 instead. Okay, so then if I did with respect to x and I just want the equation, can y'all give me the function? Okay, so it's not going to give me the function. Let's try one other technique before I let it go. Oof. So let's clear that out. Let's go to the graph. And then, let's see, calculate. Number 6. Oh, that's just going to tell us at that point too. Okay. Yeah, it'll, so this one can calculate the derivative at a point. I don't know that it can actually spit out the function. I know on my TI-89, it cannot spit out the function. So I'm just going to let that be for now. I'll offer extra credit opportunity. If somebody can show me on an 84 plus, I'm not saying that it's not possible, but if one of my students, if one of you all can figure out how to actually find the actual derivative in an 84 plus, and maybe like make a YouTube video on it, like walking us through it, and send me the link. First one to actually create something like this, if it exists, if it's possible on an 84 plus, you make that video and load it. I'll consider offering some considerable extra credit for that. Okay, I really hadn't been giving out that much extra credit, so I've been wanting to give opportunities for extra credit, so that's what we're gonna do here. All right, moving along. We actually don't have too much more to go, but we're gonna keep it moving. All right, so we get a 5v to the 3 halves plus 2v, and I think, where is it? That was example 1. Right there. You see it, 5v to the 3 halves plus 2v. Okay, and then let's work this example B. So that was 1a. Let's add a page. D by dx, x squared times e to the x. Example 1b. We're asked to find d by dx of x squared times e to the x. X squared times e to the x. Okay. So this is the product rule, right? So the way the product rule goes, this is going to be the first times the derivative of the second. So d by dx of e to the x plus the second, which is this, times the derivative of the first, d by dx of x squared. Okay. That's the product rule. This is going to give us x squared times e to the x plus the derivative of x squared is 2x. So that's going to be 2x times e to the x. Is that all they wanted us to do? Let me see. X squared. We could factor out the e to the x. We could take it a little bit further and write this as x squared plus 2x times e to the x. We could write it this way as well. Okay, I'm gonna go with this. X squared plus 2x times e to the x. Okay, let's see how do we do. Oh, they factored out the x from both of them. That's fine. They went on to factor the x as well. That's fine. Yeah, we're not gonna worry about that. Okay. So that was a demo. There was a few demos on the quotient rule. Let's talk about the. Sorry, there were a few demos on the product rule. Let's take a moment to look at the quotient rule. So the way I remember the quotient rule, basically, long story short, I think it's low D high minus high D low over low low. Okay, I'm sorry. It's funny to me. So again, low D high minus high D low over low low. See, low times the derivative of high minus the top times the derivative of the bottom over the bottom squared. Okay. So let's see that rule in action. This is going to be example 2a. Okay. So for this one, we have d by dx of the top is x squared plus 3x plus 4 over x squared minus 1. All right. So again, to do the quotient rule, I do the following. Low, which is this, d high, so that's going to be d by dx of the top, which is this x squared plus 3x plus 4. That's low d high minus high, which is the top, d low, so d by dx of this x squared minus 1, about out of space, all over low low, x squared minus 1 squared, okay? So let's do this and see what happens. So then we get x squared minus 1. That derivative there is going to become 2x plus 3. Remember, the derivative of a constant is 0. We're going to say minus, we got this x squared plus 3x plus 4. Derivative of 2x squared minus 1 is just going to be 2x. And then we're going to say all over again. I'm just going to leave this as x squared minus 1 squared for right now. Okay, let me add a page. I think I am here. Okay. If we keep going, let's see. I was trying to see if anything could factor, but I'm not seeing anything. So let's just expand it all the way out. I'll continue here. So first times the first becomes 2x cubed. Outer becomes plus 3x squared minus 2x minus 3. I'm going to distribute a negative 2x, so that becomes minus 2x cubed minus 6x squared minus 8x all over. I'm going to leave this as x squared minus 1 squared. I think that we have 2x cubed cancels a 2x cubed. Okay, then we just want to combine like terms. So then 3x squared minus 6x squared is a negative 3x squared. 2x, negative 2x minus 8x is a negative 10x. And I think we're going to have a minus 3. Two numbers that multiply to give us 9 and add to give us 10 are 9 and 1. Let's keep going. I think we could factor this, right? So then we have x squared minus 1 squared. Let me start by factoring out a negative 3 from the top. We have x squared. Oh, we can't factor out. We can factor out. Instead of factoring out negative 3, let me just factor out a negative 1. So we're going to have negative times, we're going to have 3x squared plus 10x plus 3 over x squared minus 1 squared. This gives us two numbers that multiply. Okay. So we're going to have negative, we're going to have 3x squared. I'm going to rewrite that 10 as 9 plus 1. So plus 9x plus 1x. And then plus 3. I think we're okay. Let's keep going. Okay, so what I did there, I rewrote this 10x I rewrote that as this. We have this x squared minus 1 squared. So I'm going to use factor by grouping. From college algebra, you may have used like a box method to factor here. Okay, you can use whichever factoring technique that you're most comfortable with. I'm just going to do this one just for the sake of whatever. I'm going to factor out a 3x. So we still got this negative. If we factor out a 3x, we are left with, if we factor out 3x, we're left with the x plus 3. Okay, let's keep going because that might work out for us. The hint is that we're looking for another x plus 3 over here, and I think we have it. Okay. So notice that these two terms have a common binomial factor that we can factor out. Let's keep going. So if we factor out the orange from both of them, we're going to have negative x plus 3. And then what's left, we're going to have, darn, it didn't work out the way I had hoped. 3x plus 1. I was kind of hoping we were going to have a x plus 1. If we had an x plus 1, it would have canceled. And that's what I was really looking for. Didn't quite work out. Let me make sure I did this proper. So then 3x squared, 3x, no, first outer is x plus 9x is 10x, and then plus 3. Yeah, this is correct. So nothing canceled, so that's okay. We're going to get this x squared minus 1 squared. Hopefully I did it proper. Let's see. Fine. Okay. Now, when you're working your homework, you could use things like GeoGebra, like I think Mathway works or GeoGebra. There are a lot of like online tools that you can use to crunch these derivatives and verify your work. Okay. And I mean, you know, it's okay. It's really okay. I just want you to kind of get practice. So this is what we got for part A. I just want to look at the answer. Yeah, x squared, 3x squared. Yeah, since we didn't get anything canceling, so yeah, that's fine. So we did a little bit of extra work, but that's okay. Let's go ahead and do part B. So let me add a page here. Because nothing canceled. I was kind of hoping that something would cancel, but it didn't. D by dx of e to the negative x. Okay. D by dx of e to the negative x. And this is example 2b. Okay. Let's see. Let's actually make a little change here. This is going to be the same as 1 over, this is going to be d by dx of 1 over e to the x. Let me see if this helps us. So then we need to use the quotient rule, right? So low d high minus high d low. So this is going to be low d high, so d by dx of 1, minus high d low, so d by dx of e to the x, over low, e to the x squared, right? If we account for these changes, remember the derivative of a constant is, this goes to 0. All of that goes to 0 because 0 times anything is 0. Derivative of e to the x is just e to the x, so that's going to be a negative e to the x over I'm going to leave it as, I don't know why I wrote it that way, e to the x. I'm going to leave it as e to the x squared. So it looks like we have a cancellation going on. This guy cancels one of those. And it looks like we are left with negative e to the negative x. Okay, that was a fun little adventure. Let's see, how do we do in 2b? Negative e to the negative x. Okay. Ooh, we're doing great. Oh. Let's just kind of keep going. Okay. Finding tangent lines. Finding the equation of a tangent line. Okay, so we want the equation of a tangent line. Plot the curve in the tangent line. I'm probably not going to plot the curve. I mean, I guess we could. we never really officially talked about this nature in like college algebra. Um, but we have asymptotes. We never really talked about the horizontal asymptote, vertical asymptotes, slant asymptotes, these kind of things. Anyway, let's take some time here. Let me add a page. I think I will need some space here. Right here, right? Let's add a page. Okay. So find the equation of the line. I'm going to do a little bit of extra. I might go through the nuances of graphing this by hand. Okay. So first let's find a derivative, right? So this is going to be for example 3. We have f of x equals, we have x squared plus 1 over x squared minus 4. So if we're going to do f prime of x, we got to say low, which is this guy, d high, so d by dx of the top, minus high, which is this guy, d low, so d by dx of the bottom, all over the low, x squared minus 4 squared, right? Okay. If we keep going, we have x squared minus 4 times, now that derivative there is just going to be 2x minus this x squared plus 1. The derivative there is also just 2x over, I'm going to leave this as x squared minus 4 squared, okay? Let's see. There is a common something that we can factor. So we can factor out a 2x instead of expanding those out. We can factor out, it looks like a 2x, and we're going to be left with x squared minus 4 minus x squared minus 1. Then the bottom stays as x squared minus 4 squared. Let's see. Notice that this cancels this. That's going to become what, a negative 5? Oops. So that's going to become negative 10x over x squared minus 4 squared. Okay. It says find the equation of the tangent line when x at the point 3, 2. So at the point 3, 2. So when x is 3, right? So then they're basically asking us to find f prime of 3, and that's going to be, we have 3 squared minus 4 squared divided by, under negative 10 times 3. 9 minus 4 is 5. That's a 25 on bottom. Negative 30 on top. Negative 6 by 5. So that's the slope of the tangent line. So then we're going to use y equals mx plus b. Okay. Again, at the point, I think it was 3, 2. 3, 2. So we have our slope at the point 3, 2. So then we're going to say 2 equals negative 6 by 5 times 3 plus b. What is that? Negative 18 over 5. So then 18 over 5. We're going to get a negative 10 over 18 equals b. So then b is going to be negative 5 by 9. Okay. So then the equation of our tangent line is going to be y equals the negative 6 by 5x minus 5 by 9. I think this is okay. We're going to have to go with it for now. I was going to graph this. I think I'm a little bit tired. I'm going to graph it in the graphing calculator just so you can get the concept. Okay, without having to go into all the college algebra nuances. That's the equation of the, let me see. It asks us to find the slope of the tangent line. No. Find the equation of the line to this. Okay. Right. Okay, I'm going to just let this be. Let's see. So we got negative 6 over 5x minus 5 by 9. 25 by 9. Looks like we made a mistake. 6 over 5. I thought that should have been a 5. Let me see. What did I do wrong? 6 over 5 is good. When x is 3, y is 2. 6 times 3 is a negative 18. Oh, I divided and said, okay, I see. Totally moving too fast. Let's clear this up right here. We're going to back up to this point. Okay, negative 18. So we need to add 18 by 5. So that becomes 10, 28 by 5, right? So then b is going to be 28 by 5. That's better. So then y equals negative 6 by 5 x plus 28 by 5. Okay. Man, I'm just like chock full of mistakes today. I think it's because like my mind is just already on spring break. I think that's what it is. Negative 6 by 5 x plus 28 by 5. And there it is. Okay, we're okay. And so, this graph is going to be something like this. You know, we never talked about like horizontal lines. You know, there's a lot. Like, because we're on a quarter system, so it's a little bit of a challenge. I know we touched on it briefly, but, you know, we don't have the luxury of going into the details like I would like to because we're on a quarter system. But yeah, we'll get an image like this. Okay, that was fun. We're almost there. So we're going to let that be. Let's see. Extending the power rule to negative integers. So the power rule in a general form. So the d by dx of a power function is going to be the exponent times x to the power of n minus 1. Okay. Kind of tired, but let me go ahead and do these. I think we can do them. Use the power rule. Find the following derivatives. There should be a trick one, but I'm not gonna. Okay, yeah, let's do these. So let's do example 4a. We're definitely gonna need some paper or some space. It's right there. Add a page. Okay, the x is to do d by dx of 9 over x to the 5, right? I'm going to actually rewrite this. This is going to be the same as d by dx of 9x to the negative 5. Negative 5, right? So then if we use the power rule, this should be 9 times 5. That's going to be a negative 45x to the negative 6. And then I'm just going to put it back. Negative 45 over x to the 6. I think that's the result there. Let me see how did they write their answers for part A. Negative 45 divided by x to the 6. Awesome. Let's go ahead and do 4b. Example 4b. We got d by dt, or the derivative with respect to t of, we got 3t to the power of 16 minus 4 over t to the power of 6. I don't know what our time is like. I'm just going to finish out this section. I know we've been going pretty well. I'm just going to finish out this section and we're going to call it a day. All right. So what I'm going to do, because we're dividing by a monomial, I'm going to distribute that monomial into the top, right? So this is going to be the same as d by dt of 16, t to the 16 divided by t to the 6 is going to be 3t to the 10 minus 4t to the negative 6. Okay, so now if we take the derivative of that, it's going to become 30t to the 9 plus 24t to the negative 7. And I'm going to just take it one step further. 30t to the 9 plus 24 over t to the 7. Okay, let's see how do we do here. Okay. 30t to the 9, 24 over t to the 7. 30t to the 9, 24. Did they leave it like that? They surely did. So that's the only thing. I just need them to be consistent. Like, I don't see why in part A they put they wrote it as a positive exponent. This derivative can be evaluated, but alternative methods write it in negative powers. That's what we did. We now differentiate, and they left it like that. That's fine. I mean, and it does mean the same thing. I just do my best to be consistent, and like they are being a little bit inconsistent, but it's actually okay. It does mean the same thing. So anyway, let's keep going. Let's do part C. Part C says we got the cube root of z times e to the z. Cube root of z times e to the z. D by dz, Dragon Ball Z. Arr, dragon. Anyway, this is, what is this, 4C. Oh no, go away. Thank you. Example, let's see, that whole thing just threw me off. Look at this. Y'all, you're just tripping right now. Okay, undo. We're doing example 4C. So I think when I get off of here, first I'm gonna just like stretch, go walk the dog. Then I probably do some gaming. I might come live over the break just to do some gaming. If any of my students, I don't know who's listening, but if anybody does, I only play 2 games. I refuse, for some reason I will not pick up Fortnite. The students was like, Mr. Pfeiffer, you need to play Fortnite. I was like, I know, but I'm not going to. So I only play 2 games right now. I only play Mobile Legends and Dokkan Battle. I started playing Dragon Ball Legends. It's fun, but I just don't want to pick up any more games. They can be expensive and a waste of time. So I've been phasing those out of my life because I'm trying to like move on with my life so I can have a life and build a life. Not that I couldn't build a life on gaming. There are plenty of people that like make a good living doing gaming. I just don't want to do that. I want to actually be outside. I'm an outdoorsy kind of person, so I'm always trying to find ways to get outside and things of that nature. But anyway, so let's go ahead and do this one. We only have a little bit left. Let's see. Okay, we can use the product rule here. Okay, so if we're going to do this is going to be the first times the derivative of the second. So we're going to say, I'm going to rewrite this as z to the power of 1/3. The first times the derivative of the second, so d by dz of e to the z, plus the second, which is this, times the derivative of the first, d by dz of z to the 1/3, right? Okay, let's do these. So the derivative of e is itself, so this is going to stay as z to the 1/3 times e to the z plus, now when we take the derivative of the second one, z to the third is going to become 1/3 times z to the negative 2/3 times e to the z, okay? We can at least factor out the e to the z. So this is going to be the same as the cube root of z plus, on the bottom we're going to have 3 times the cube root of z. I'm going to write it like this, is squared under 1, and then all of that times e to the z. That one's just to me, it's just more of a preference of how they want to show the final answer. Okay. So also, like yesterday, it took me maybe a day, maybe 2 days. I ended up binging the Tiger King. That was a fantastic story. I felt so bad for the people though. Like I could just sympathize. I honestly sympathize with the Tiger King, even though like just at like first glance, like his presentation and his style, I totally did not agree with. But that woman was like harassing him. Anyway, I don't want to spoil it if you do want to watch it, but just check it out. And if you ever want to talk about it, I totally want to talk about it because I feel some kind of way about it. But it is what it is. It's a story. I'm hoping that all those people are okay. But yeah, that was like, man, that just looked rough. Let's look at example 4C. 4C, how do we do? I just want to see that one. I think they got the same thing. E to the 1 plus 3z. Let me see. Oh, they rationalize? Oh, got a common denominator and all that jazz? I think I'm going to just leave my answer as is. I don't feel like doing all that. Because I see it here. Let me look at it. They did get a common denominator. Yeah, we got 1/3. They went on and got a common denominator. Man, I'm just going to leave mine. It's fine. So yeah, you can take it a little bit further. I'm just going to leave it like this for now, though. And let me go ahead and do 4D. 4D, I'm going to leave that as an exercise. I'm not going to do that right now. I'm totally tired. Now, if you need me to do it, I will, or if you need to discuss it, we can. I'm going to leave 4D as an exercise. Okay. So it's here. Some situations call for the use of multiple differentiation rules. This section concludes with one such example. So you have like the quotient rule. Let me go ahead and do this one. I feel like we need to do this one. And I think this will be the last one for the day. So let me add a page. Okay. All right. So example 5. We have y equals, now on bottom we have x squared plus 1. On top we have 4x e to the x. Find the derivative, okay? So if we're going to do y prime, that's going to be low. I'm going to use the quotient rule. So the bottom times the derivative of the top. So we're going to say d by dx of this thing minus the top times the derivative of the bottom, d by dx of x squared plus 1, all over the bottom squared. Okay. All right. Let me keep going. All right. So then if we account for these changes, the x squared plus 1 persists. So the derivative there, we need to use the product rule. I'm actually using the constant rule and the product rule. I'm gonna just do them in one go though. So the first times so this is gonna be the first times the derivative of the second, which is this, plus the second times the derivative of the first. Derivative of 4x is just 4, so that's gonna be 4 e to the x. And then we're gonna keep going. Minus 4x e to the x. And that derivative is just 2x. And we're going to say all over x squared plus 1 squared. Okay. Let's see. Anything that we can factor out? It looks like there is at least an e to the x to every term. And it looks like there's a 4x. There's a 4 e to the x. It looks like everything has at least 1 4 e to the x. Let me factor that out. I think I'm just going to expand it. I'd rather just expand it. We can factor out a 4 e to the x there, a 4 e to the x there. Let me just factor that out. So then we're going to have 4 e to the x. Now what's left? Let me see. In this first one, this persists, x squared plus 1. And actually, we need to do something like this. 4 e to the x. So x is left there, and a 1 is left there. Okay. Then we're going to say minus 4 e to the x. So that's going to be minus what? 2x squared. Okay, this is fine. And then on bottom, we still have this x squared plus 1 squared. Okay. Okay, let's keep going. Let's see if we can get this down in a 4e. Nope. 4e to the x. If we expand that, that's going to become what? X cubed outer plus x squared plus x plus 1 minus 2x squared over x squared plus 1 squared. Okay. 1 minus 2 is negative 1. So then we'll get this negative x squared plus x plus 1 over, okay, let's see. Can we factor that? If we did factor by grouping, will that work? Let's try factor by grouping here and see what happens. If we look at the first two, yeah, let's just do it. Okay, so we get this 4 e to the x. Now from the first two, we can factor out an x squared, and we're going to be left with, oh, it doesn't like it's going to work. Let's just try. Oh, wait a minute, did those cancel? Oh no, that's supposed to be x cubed. All right, this is supposed to be x cubed. So then we're going to be left with what? X minus 1 Oh, so close. Nope, that's not going to work, right? Because we don't have the x minus 1 in the second part. If that were a plus, we would be there. Dang, so close. Okay, I can't see anything canceling. Yeah, I'm not gonna, so I'm actually just gonna stop there. Let's see what the original question said. Find a derivative. I can't get anything to cancel. I'm gonna go with this. Let's see how do we do. Let's see how do we do. So that's there like that style. Okay, let's see how do we do. So I'm gonna get rid of the extra page. And let's see. Sample 5. Oh. Let me just copy and paste so they can be side by side. And let's actually go ahead and do this paper since we are essentially done. Let me get a copy of this guy because I just want to hold it up next to the answer and do my little celebration dance. Do a little dance. Get down tonight. All right. Oh no, what happened? Let's just undo. Okay, that's all I wanted. Okay, 4e to the x cubed minus x squared plus x plus 1, x squared plus 1 squared. Do a little dance. Get down tonight. You got to celebrate whenever you can. All right. So, on that note, we're actually going to end this session here. Okay. So hopefully, you were able to get something useful from that experience. Just to kind of recap. So we're going to go ahead and close out here. This will close out for going into spring break. So a few notes. The main thing is, one, there is a participation and honesty quiz on Moodle. Go ahead and submit that quiz. It should be very quick. It's just something that you need to go through and submit. There's also a quiz on Pearson. So whatever assignments you see on Pearson, I think I took all day yesterday to just update Pearson. I tried to reach out to students that were kind of at risk, making sure that people were aware of how to access the full complimentary, get full complimentary access and things of that nature. So we just want to go ahead and honor the deadlines that are on Pearson for the assignments. Everything is posted. Once you finish that work, I would honestly take a break. Like, we're going into spring break, okay? So just do what you feel like you need to do. But be sure to take a break because you don't want to burn yourself out trying to like work through the break and then we come back and you never got a chance to rest. Okay? If you have questions, you have to reach out to me, write them down, email me, call my office phone. I'm available. I make use of the Ask My Instructor in Pearson. I make dedicated YouTube videos walking you all through your questions, okay? And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day.